In the late 1970s, satellites such as the Nimbus 7 satellite relied on NASA's ground stations located around the world to provide a communication network. This ground-based network could only provide communication over 15% of the satellite's orbit. With its ever-expanding orbiting fleet of satellites and manned spaceflights, NASA had to increase the coverage and develop an improved way to track and communicate. In 1983, NASA launched the first of a series of new communication and navigation satellites that would rely less on international ground stations and provide continuous coverage. Tracking and Data Relay Satellites, TDRS, are a network of geosynchronous communication satellites that work in conjunction with two ground stations. Today, NASA's fleet of spacecraft and launch vehicles, like the Tropical Rainfall Measuring Mission, TRMM, can communicate and navigate with the help of TDRS. This interaction between TDRS and the spacecraft is a series of complicated signals that guarantees that every Earth-orbiting spacecraft will have nearly non-stop coverage. The International Space Station, ISS, routes voice and video communications along with data through the TDRS fleet. The Hubble Space Telescope also utilizes the full capabilities of TDRS. TDRS supports the Hubble's real-time interactions with the ground systems, allowing observers to make small adjustments to its observatory system. TDRS provides the Earth-observing system of satellites, such as the Aura spacecraft, with low-latency data relay and navigation data. The TDRS network sends all of these data streams and voice communications to either the White Sands complex in New Mexico or the Guam Remote Ground Terminal. Guam then transmits the data it receives to White Sands. The White Sands complex then relays it to the end user at their missions operations centers. As long as there's space exploration, TDRS will be working side by side with spacecraft and end user, providing continuous connectivity for navigation, data, and voice communications.